As I said, I used to work in the food industry before I came to Kent. And there I used to work a lot with, we were interested in quality control. We were interested in, making sure that there wasn't any bad contaminants or anything else that was going on there. Exactly those things are interesting in forensic science. In forensic science, we want to be able to identify. If we've taken a suspicious substance from a scene of a crime, we want to be able to identify exactly what that is, why that's there, why is it interesting. So we want to be able to identify if we take some kind of red substance from the scene of a crime. We want to identify not only getting DNA evidence, but we might want to identify if there's any other components of that blood or that are of interest. Maybe there's some other stain at the scene of a crime. These days, at the moment, you have simple presumptive tests that allow us to say yes or no, that particular stain at the scene of a crime is potentially some kind of bodily fluid. Is it yes or no? Maybe you're starting to identify it. What if we could get much more high resolution information about it, as I was talked about? Now, the problem is, in order to get those high resolution information at the moment, we have to take everything we've got and take it back to a lab. And that's what happens in the forensic labs. They have fantastic, this is an HPLC machine that you can see on the slide here. We are able to take this and gather this information in a lab after it's been gathered at the scene of crime, but that takes days. And this is so often where forensics on TV breaks down a little bit, because of the fact that in real life, that isn't actually what happens, and it's not that simple and easy to gather information so quickly. It takes days in order to do this with very meticulous processes. And that's important to get the legal thing. But the trouble is, because the kit is so big and bulky and heavy and hard to use and needs those experts in order to use it, you need to have all those training, and it needs to have a big infrastructure in a lab to do it. So the speed isn't there. We're not able, in the case of, for example, a capping or something like that, when you might want to have a very rapid turnaround in understanding in order to respond to the situation, we don't have the speed to be able to do that. We're not able to respond quickly. We're not able to bring the portable things together. So I asked the question, because this is one of my interests, and this is what we do. What if we can take this analytical kit back into the field? So what if we can take these big bulky bits of equipment, shrink them down so that they can then be taken back into the field where evidence gathering teams, where our senior crime officers are, in order to give much more rapid response to any investigating officer, so they can actually say, oh, and provide more information in order to respond rapidly to a particular crime. And we do this. I work on this a lot within the group, and we're working on exactly this, trying to take these analytical techniques and kind of reducing them down in size, so that you go from something that's large to something that sits in the palm of your hand. And I have a number of people, a number of students who work in my team. I have a number of students who have worked in my team previously, who've graduated and then stayed on to carry on doing this research with me, working on these techniques. And one of the primary techniques that we use is a technique called microfluidics. And microfluidics works by using the flow of liquid and its interaction with surfaces in order to separate particular materials from it.